Right, so I want to start with section 1.6 and some of 1.7. And this is going to be an intro to proofs. And basically what we're going to do in this section is just cover a number of different proof techniques, and we'll learn a few basic terms so that we can start proving things. So your suggested exercises are 9, 13, 21, and 39. And if you're in the 7th edition, these are going to be the same problems, but it's going to be in section 1.7. So it's 1.7, problems numbered 9, 13, 21, and 39. But we're also going to cover some material from 1.8. Okay. So if you're in the 7th edition book, it's sections 1.6. Sorry, if you're in the 6th edition book, it's sections 1.6 and 1.7. If you're in the 7th edition book, it's sections 1.7 and 1.8. So the main things that I want to discuss in this section are just going to be the introductory topics for proving things. We're going to talk about what is a theorem, what is an axiom, what is a proof. We're going to talk about even numbers. We're going to talk about odd numbers. We're going to talk about rational numbers. And then we're going to go through the following types of proof. And these, again, you're going to hear me say numerous times, these aren't hard categories like it is this and is not that. These are more like flavors. Like, something can be salty or something can be sweet or something can be salty and sweet. So these are just types that can overlap. There's going to be a direct proof. We're going to have a proof by contraposition. We're going to have a proof by contradiction. Whoa. And we're going to have a proof by cases. And I would just say, you don't have to carefully work through, but look at all of the examples that you can stomach. Okay, because this is a skill that you learn by doing. So you're going to need to, try to write these things down, but that's going to be, it might be tough for you at first. So I would look at all the examples you can and then work through some. Okay, it's writing proofs it tends to be hard for people when they've never written proofs before. And you'll see what we're doing here is not necessarily the 2-column proof that you might have done in like a high school geometry class. We're a little bit more lax. But this is a skill that needs to be practiced. It's not something that you just look at the night before the exam and expect to do well with. Okay, so some people can, but for most of us, it takes practice. And you'll hear me talk more about that as we go on. So let's start. So an axiom is a statement that is generally accepted to be true. So what does that mean? What's a statement that's generally accepted to be true? So when I say an axiom, this is like a super fundamental, basic assumption. So these are things like 0 does not equal 1. Okay, that is probably not a controversial assumption. But as soon as I start making statements like pi is irrational, you might have some pushback. Okay, now pi is irrational, but that's a lot harder to convince someone than, say, 0 doesn't equal 1. And 0 can actually be equivalent to 1 in certain senses. So it really depends. So axioms are something that we generally accept to be true, but occasionally we modify the axioms and then we state it. An example is many of us have probably seen plane geometry, or what we call Euclidean geometry, but then if you've watched some sci-fi or maybe done some Wikipedia holing, you might have heard of non-Euclidean geometry, which is where we reject one of the axioms that Euclid started with. And you can do a whole lot of neat things with that. And this is, if this was a live class, this is where someone would raise their hand and say, oh, did you know that the universe is non-Euclidean? And that's when we say, well, you know, there are models, and then there are questions of what is reality, and, you know, that's when you go listen to some Tool and think really hard about what existence is. We're not going to go there. What we're going to do is say a theorem is a statement that can be logically derived by a sequence of statements and axioms that, whoops, I'm getting redundant here, that logically imply one another. So I guess I used the word logical twice there. There's maybe, what do I have written in my notes? A theorem is a statement that can be logically deduced from axioms. Okay. So a proof is this series of deductions.